This is dry ice, submerged in water. But wait, how can ice be dry? And why is it called dry ice? All of your burning questions will be answered shortly.
Dry ice is actually not ice, but rather frozen carbon dioxide. With this being the case, what coined the term dry ice? Well, dry ice is actually the name of Dry Ice Corporation, which first tested frozen carbon dioxide for railroad cars to be able to refrigerate food while transporting them.
Well, now that we know the origin of the term, the next thing to ask is, why call it dry ice? Well, this has something to do with its distinct characteristics that differentiates it from its more common brother, regular ice. The things they have in common is that they are both solids and that they're both relatively cold. However, their chemical composition is completely different, since normal ice is just made from water when it solidifies or freezes, but dry ice is made from carbon dioxide molecules. This means that the phase changes they undergo are completely different.
As you can see and probably know by now, dry ice is solid, which currently is turning into gas without passing through the liquid state. This process is called sublimation, when a solid turns to gas without going through the liquid state first. The compressed carbon dioxide molecules are turning into gas as the pressure is decreasing, as they are spreading out and away from each other, and the temperature is increasing.
Sublimation is the phase change in which a solid turns into a gas without passing through the liquid phase. This is very uncommon because it skips the liquid phase before turning to a gas. Pretty weird, right? But it does happen.
The reason that it's so unique is the fact that it bypasses the liquid state, just like what she said. Turning a solid, straight into gas without turning into a liquid first. However, not all substances have the capacity to do this. Another example of sublimation is when you use mothballs. Unfortunately, one of our group members cannot be exposed to naphthalene, which is a key component of mothballs. Consequently, we can't use them for our demonstration.
And he also isn't here right now. Okay, so moving on. If the opposite of freezing is melting, and the same goes for evaporation and condensation, then the counterpart of sublimation is deposition. Being the reverse of sublimation, the process is flipped. Now, gas to solid, but also without passing through the liquid state. It is also uncommon like its counterpart. One example you haven't mentioned yet is snow. Snow. We don't have that here right now, but basically what happens is that the water vapor comes in contact with a very low temperature and therefore turns into ice or snowflakes.
The factors that affect these changes are both temperature and pressure. If the temperature goes down, the molecules will start to move less and less, just like how they would as stated in the kinetic molecular theory, right there. And when you add pressure to something, this will cause the molecules to move closer and closer together. As I mentioned before, dry ice is just frozen carbon dioxide. Therefore, if you heat it up enough, it will have enough energy to move freely so that it's from solid, it will have enough energy and that it will go straight into gas, quickly bypassing the liquid state. The same logic applies for deposition, but the other way around.
In the water cycle, there is snow, which does not happen in tropical countries. Since rain is formed from condensed water vapor, snow is formed from depositing water vapor. Because of this, snow is much colder than rain. When snow falls from the sky, this season is what we call winter. It's much colder during the season. Also, when the season ends, snow piled up from winter will turn back into water vapor, which is the process of sublimation.
And now we have our experiment, the sublimation and deposition of iodine.
Woo!
So, warning, don't do this at home without adult supervision. And don't forget to read the MSDS or Material Safety Data Sheet of iodine. So you can see, these are iodine drills. Wow. And I put some in advance. Now we're going to heat them up.
Make sure that you are being supervised by an adult while doing this, because using materials that have been tampered with or faulty materials will probably make this thing explode.
So you can see the solid iodine is now turning into purple smoke. This process is called sublimation. Whoa, see, it's so pretty.
It's so beautiful.
Like,
Sure, why not?
and now, stop that. Going to cool them down, cool the gas down, and it's going to slowly turn back into a solid, which is the process of deposition. Right there. You see those flakes there? Those were gas. Yeah.
Eventually, all of the gas will turn back into solids and become iodine pills again.
Don't touch the bottom of the beaker.
It's really hot.
Yeah. Anyway,
Well, that does it for our video. Hope you learned something new today and have a nice day.